Danilo, can you hear me? Okay, very good. Any request of questions to be solved from the homework? Okay. No. Very good. Not a lot of people today. 10, 11. Next class we'll have some active learning, so expect. I suggest that everybody will arrive. We'll do a few interactive things next class, but we'll wait with them and time to start. Yeah, let's talk about the homework questions. I'll get back to the questions about the skip list. In the meantime, let's talk about the easiest question, I think, in the homework, which asked for a data structure, which in this context can be only hashing, that you can insert a word into the data structure, you can delete the word, or you can find the word in the data structure. So, however, the word could be identical to another word, even if the spelling is a bit different, as long as the only difference is just that I'm using small letters over here and I'm using some mixture of small and large and capital letters over here. And the idea was to get the idea of canonization, to think about the canonical shape of a key. And what is canonical shape? It is exactly what you want it to be. It can be anything you want, but the idea is that if I have two identical items, I have a key 1, which might be the low capital, and K2, which would be a different way to write the same word. In both cases, I will bring the two keys into the canonical shape, which could be what? I can decide whatever I want. I'll decide that the canonical shape would be, I'll use only capital letters to write this word, which implies that now if I insert K1 and I'm searching for K2, before I insert K1, I'll shift it to the canonical form, which would be replace all the small letters by capital one, and this is the key that you insert. Now you're searching for a word, take the key and write again, canonicalize it. And all I need from the canonical form is that it will end up in the same way no matter what I insert or what I delete. A full answer is still asking you when you're using a hash function to tell me which hash function you're using, what's the size of the table, and what would be your idea about extending the table. You can add a few details that I can be more specific or less specific about inserting them. But which hash function can we have? That's pretty much, what should be my hash function that can accept strings, given that every string can contain up to 50 characters. It's a large, it's a respectable string. Which hash function do we know that we can access a long string? We want to use a dot product, right? Remember, sigma of AI, ki. Well, ki here might be just the individual characters, and AI are variables that I take. Ki might be just the ASCII value of each character, and do all of it mod m, where m is the size of the table, and a full answer. It was not very specific in the details because it was mostly warm-up for the next question, but a full answer, you should also say that, are you using chain hashing or open addressing? If you are using open addressing, why not? It's easier. Open addressing, then you want to make sure that m, the number of cells in the table, is large or equal than to n, the number of keys that you are going to insert, and if not, then you double the size. So that would be, if you want, a perfect answer. And okay, question 3. I have a 3 by 3 or k by k tic-tac-toe game, and I'll convert it, of course, into a vector. So I'll assign for every cell a number which can be either 0 or 1 or 2. 0 if it is empty, 1 if it is an X, and 2 if it is an O. And now I can look at the sequence of the K values, that of the K square values that I'll get, right? K1, K2, dot, 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 all the way up to K9, if the game is 3 by 3. Right, I have 9 values, 1 value per each cell. And I'm looking at this vector, list of number. Think about it as K1, K2, all the way up to K9, or in general, it's a pretty bad use of the letter K, but as usual, if the game is of size, say, L by L, then the length L by L, then the length of this vector will be L squared. And every number is between 0 or 1 or 2. So I need 2 bits per each number. I assume that most people got to here without any questions. You can think about other ways to represent this vector. No matter what you'll do, it will end up to be a vector, one way or another, a list of numbers. And I can now make this vector, I can read it as just one number, a sequence of bits, but that will be a pretty large number, not in the case of 3 by 3, but in the case of where L is a bit larger number, and also I don't feel necessarily any need immediately to make it into a number. I can, to hash it, age of V, where of this vector, I can use once again the dot product from over here, where ki are these numbers, if you want. And that is pretty much a fail-proof approach. look at these numbers and just multiply by the set. If you didn't say dot product, since L can be large and the sequence can be quite large, if you didn't say anything about the dot product method, then it's not a full answer. And next, we are getting to the question of what am I actually want to store, given that for the same configuration, there could be 8 different settings that are all equivalent in our world, right? I should rotate it by 90, 180 or 270 degrees, and I can do a mirror flip. So I have 8 possible configurations, and I don't want to store the whole 8. But that means that I have to find a canonical configuration that will, some canonical configuration that will take this configuration and possibly rotate it, possibly do a mirror flip, but eventually if I'm doing a search or an insert, even if one is rotated with respect to the other, I'll do before I'm doing the insert and before I'm doing the search, I'll move both of them to the same canonical configuration, this expression of the equivalent of the expression with only capital letters. So how, and of course you need to say out of the 8 configuration, the canonical one should be unique. When I see it, I need to recognize, yes, that's what I was looking for. What my proposal would be is to think about this vector, k1 all the way up to k9, and let's look at v prime that would be k1 prime dot 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 k9 prime. Let's say that this is obtained from this by rotate by 90 degrees rotation. So that's a different vector. I can ask in lexicographic order which one is smaller than which. Again, in a lexicographical order, which one are smaller? What is lexicographical order? The same order that you have in the phone book. Everything that is sorted alphabetically. If you sort names alphabetically, you'll say 2 people that have the same family name, we'll sort them based on the first name. If they have the same first name and family name, we'll use the next data item to sort them. Right? So if K1 will say that V is smaller than V prime, if either K1 is smaller than K1 prime, or they are equal, but then K2 should be smaller than K2 prime, and so on. So that's one way to define the canonical configuration. I'll consider all the 8 rotations, look at the vector that they are producing, and look for the smallest key out of them. Smallest in the sense that it's lexicographically smallest, or if you don't like this extra term that you add some more complexity to the question. This is a number that is written here, right? I can represent K9 as with 2 bits, either 00 or 01 or 11. I can represent K2 as one of these numbers, right? 0, 0, 0, 1 or 1, 0. Why 1, 1, 1, 0? And so on. Look at this. It's still a number that I represent. I mentioned many times that it's not a nice number to work with respect to a hash value, like multiplying this number when L starts to be large, then this becoming a huge number, and I don't want to multiply it by other constants. It's computationally expensive. It's not convenient to do multiplication or very long integers. But I can still look at this as a pretty large number and ask, is this smaller than another pretty large number? That's easy. So I'll just pick, say, the minimum out of all the configuration and call this one the canonical configuration. And in this way, I know that it's unique, and I know that even in the rotation, even if the query is different than the configuration that I inserted to the data structure, in the query, it's the same configuration up to rotation or flipping, then I'm just doing the reverse operations and I'll end up with the same canonical form. Everybody cool with this? So you'll just decide that it's the smallest, or you'll just decide that it is the largest, or I heard from people a few other options. One of you suggested to use a hash function of the upper part and the lower part, which sounded very good, and I was trying to hint that it would work even better if you didn't take the modulo of this number. If you're taking the number itself and you don't take the modulo, then you know that this number is unique. You don't have two configurations that after the modulo yields the same number. Okay, so that takes care of question B. So in this aspect, you are doing the canonization before you insert, and you're doing the canonization before you do the query. So you're performing only one query, and you are insert on the configuration only once. And C, the same way, taking back to 1, except that each one of these values, K1, K2, all the way to K9, now instead of only 3 possibilities, you'll have, say, the number of pieces of chess that can be there. Soldiers, king, peon, and so on. People, questions? Okay, let's move to 5 and then go back to 4. 5 says I want to find, if I have two identical files, I can use the MD5 of these files. So I can ask my operating system, what is the MD5 of homework2.pdf, homework2.pdf, and I'll get some number in return. What do I do with all these numbers? So the bad idea, obviously we want to insert them into a hash table. We want to use a hash table, and I want to use this value, let's call it K, that would be the MD5 of homework2.pdf. I want to use K as an index into a table, such that, what do I know about file 1 and file 2? So if I think about any hash function, MD5 for example, if the hash function of file 1 n is equal to this hash function of file 2, does it tell me necessarily if that the files are identical? No, even though in MD5, because it's pretty large, the probability that they are not equal is pretty minimal, but when Sony was suing people for copyright violation, you want to be, you need a proof that the files that I stored on my hard drive illegally is actually the file that I was getting in a pirate way, and it's not legit. So you need to actually check bit by bit. However, if the hash function of file 1 equals to the hash function of file 2, then possibly they're identical, high probabilities that they're identical, but some probabilities that they are not. However, if the hash function of file 1 is if the hash function of file 1 is different than the same hash function of file 2, then obviously these files are different and there is no point of checking them bit by bit. So I'm thinking about the hash function as a way to filter a lot of pairs of files that otherwise I should have started to check bit by bit whether or not they are identical. But this operation of checking a lot of pairs bit by bit is expensive. But I also discourage you in the question because I said the number of files is huge. I also discourage you from checking all pairs of files to see if the MD5s is the same. I don't want you to check a lot of pairs of files. I want you to check very few pairs. So how would you do it? It's easier to visualize if we are using chain hashing. Then let's insert here all the files for which age of each one of these files. If this is cell 17, then I want age of this each one of the file here, F1, F2, and F3. The age of each one of them should have been 17. Say it would be nice if I can use the MD5. And now when a new file comes and it's when F4 appears, the fourth file, I compute its hash function, said that it's 17 as well. Then I'm going to this cell of the table and I think about inserting F4 into this list, but before that I need to check if F4 is identical to F1 or F2 or F3 because they all have the same hash value, so they are quite suspicious to be the same file. So it's tempting to use the MD5 as the hash function into this table, except that it's not practical. Why is this not practical? Because MD5 returns a number that could be as large as 2 to the 127. That could be the maximum value, and if you think how much memory you need in this table, that's the number of cells that you can have, which is quite large for you, for Google, for everybody. And you don't need it. What do you need instead is another hash function, and you need the idea that the hash function that we are using for indexing to decide where we place the file in the table, and the hash function by which we are checking if two files are similar, this should not be the same hash function. You need another hash function that will work on the MD5, and this hash function can be quite simple. For example, I will say that age of k is just k mod m. Right? What do I do by this? And then the key, the place to which I'm inserting the file would be to which index do I insert homework2.pdf. I'll compute the MD5 of homework2.pdf or of F1. What I'll store with F1 is its MD5 value. So I store it with F1, but as an auxiliary data, the satellite data that sits with the table. The key that I'm using is not immediately the MD5, but my hash function that works on the MD5, and this function age will be an index in the table between 0 and say to the 20. You have million cells here, maybe it's enough. Whatever the number of files that I specified there times 2, that's the size of the table that you need to store. or at least something in the same order of magnitude. So, and there is nothing wrong of using this hash function as h. Just take this very large number that MD5 gives you and do the modulo. Of course, the chance of collision here goes smaller. The smaller m is, the higher the chance of false positive, that you have two different files with the same hash value. But that's okay. You're not wasting your time checking the file bit by bit immediately. You have a hierarchy of checks, right? I first check if the age of the MD5 of homework 2 and of F1 is the same. If yes, then I'm checking the exact MD5. It's a large number, implying that my chance of false detection is much smaller. And only if I pass the MD5 check successfully, only then I'm going and checking the file byte by byte, bit by bit. Okay, so back to question 4, you just have to write yourself the MD5. And to do it, well, it's obvious. It's large files. Use the dot product. You cannot do it with only one multiplication, or you cannot take a large document. You can do, but it's not efficient to take a large document and multiply it by a large number and hope that it will be a good hash function. Okay, other things from this homework that you want me to chat about? If you used MD5 directly as index, then yes, because I sent all the feedback in the world. You are going to be hired based on this project. It needs to be practical. So it's, yeah, I said here, it needs to run on your desktop. So the mistake would be to suggest MD5 directly as a hash key. If you didn't say what the size of the table, but you use a function that runs on the MD5, then you'll deduct something just to note that there was an error there, so it will be 1, 2 points. It's
part of what my suggestion was instead of using like the MD5 directly, would be to grab like to grab a selection of bits from the middle of the string for the hash. Would that work?
perfect. Perfect. As long as we realize that the MD5 is not the index of the table, but it's a very good predictor of whether files are identical or not, then yes, taking a few bits from the MD5 is a perfectly ideal. And I don't know if it's different than taking the modulo, but I think that it's a better idea than what I'm suggesting. It's exactly the don't take the last bits, don't take the bits at the beginning, take from the middle. I'm happily adopting it, and and yeah, I like this idea.
I had another question about the homework in general.
Sure.
Similar of answers do we need to give to yours in order to give them credit? Like if we take I guess a similar but different approach, like in the case of the hash table that we just went over, like using the MD5, moduloing it by the hash table size, and then just like comparing files and collisions. Is that still like a fully correct answer? Or are you also looking for us to store the MD5 as well?
How do you know that two files have the same hash value? I didn't say it specifically, but I need to store it in a table so that I will not compare every pair of files. Right? I'm trying to minimize both the number of cases of false positives, that I'm checking files that are not identical, but I'm also trying to minimize the number of pairs that I'm checking at all. So something that runs in n square, something that runs in n choose 2, which is, theta of n square, would be less preferable, and that's why we are using the table. Is just that I'll only check a file or even the MD5 of a file against other files that falls into the same entry.
Okay, so I guess that's the same answer I had. I think I just misspoke. So I guess what I'm getting is if we have answers that have similar runtime to yours, then we probably have an answer that could get full points, even though it might be different.
It's the only difference is that are you checking all pairs of files, or do you have or are you using the hash table to or other methods that I don't see right now. But if you're using any way that avoid checking each pairs of files, then you are safe. You can insert them also into a search tree, but it's less efficient than hash table. Anything else from the homework that you want me? Sure. That the bonus points are the OP points, right? That it's stored separately in D2L. We didn't export yet the grades into D2L, but in D2L you'll have one column of the normal grade and one column for the grade in the bonus for each one of the homeworks. So you have the homework grade, no, homework 1 grade, and homework 1 bonus. And I would think that I don't want to quantify it into numbers, but there, in terms of recommendation letters, my opinion about you as a student as a whole, definitely what I'll do if your grade is, if your numerical grade is between two grades, then I'm looking at each individual grade individually. It's less about the number, it's more about what I think about you. Help me think or communicate later in the recommendation letter what did I think that you did the extra work, found the more challenging questions. So mhm. The sum of the points is still 100. The number of the non-bonus sums up to 100, or slightly more than 100. So you can get the 100 independently. But no, I could have taken a different policy, but then I had to state it at the beginning of the course. And the policy that I stated several times is that this is a policy, that you're getting to 100 and you have the bonus question to show that you are at the top of the list, that you are competing among the better students, that among the I don't know, we are 50, about 15 to 20% of you, maybe a bit more, a bit less, will get an A. How do I rank between people in this, between the A's, will be using the bonus points. So talking about bonus questions, the bonus question here that you had to sum up transaction and ask what is the sum of transaction between date 1 and date 2. It's taking us, of course, into question 1, where you had a skip list and you store this size value, that namely that says how many keys I have between this key to the next key in my own level. If I'll insert a new key over here, then I need to update the size, increment it by 1. If a new element is inserted into both levels, level 1 and level 2, then I need to now update the size of both the element before it and the element after it. I need to update the size of the element before it. But if I'll insert an element right here, then the size of this guy will still be 2, right, 1 and 2 element until the next one, and the size of the new element that sits right here will be 2 as well, all the way up to the next one. And it's a bit of a headache, but not too much, and you can update it, and I recommend to update the size values on the way up. That is, first to insert the key wherever it needs to go, and then update the size value in every cell that need to be updated. Because when you are not inserting into the into the lowest level, the calculation is a bit harder. You need to sum up how much it is, but you can get it by the size. You can always know what is the size field in level 2 based on the size field of level 1. And you can always know what is the size field of level 2 based on the size field. You can always know what is the size field of an element in level 3 based on the size fields of constant number of elements in level 2. So that's about the size fields. Then you had a question that asks how many keys do I have between one element and another, between 2 keys. So I just sum up the size fields, asking how many elements, what's the rank of, say, 40, what's the rank of 13, say, between 13 and 40, do this calculation, do the summation along the search path, figuring out what's the rank of 13, what's the rank of 40, and the difference in the rank tells me how many keys there are between 13 and 40. If I'm summing up transactions, then instead of having the size as the number of keys between me and the next element, I'll change the size property to store the sum of transactions between me and the next element. So the size value of this element will be the sum of all the transactions that happens between this date, including, all the way up to the next element in this level, not including transactions that happened in this date. And then you're just taking again the difference between date 1 and date 2, and that gives you the sum of transactions that happens between these 2 dates. What else did we have in this question? That's one we did in class. Hopefully everybody saw it. It's just the pigeonhole principle. Pick one of the cells should contain more than 10 keys, so the adversary just returns this cell, all the elements that falls into this cell. And the last question just said that if we look at this formula, what it says is if I'm summing up 2 large numbers and then I'm going to compute their modulo, I might as well compute the modulo of each number first and then sum them up. So if I'm doing it modulo 7, then this number will be smaller than 7. this number will be smaller than 7. Their sum might be larger than 7. That's why I need to do modulo once again. Only then I could have written equal to. People that took math or abstract algebra will say you don't need to use equal, you can use equivalent to, and then it's congruent between groups. I know, never mind. If I want to write equal to, then I need to do the modulo more than once, but I can always keep all the numbers not more than m. If I see that a number becomes larger than m, compute its modulo, and you never change the final result. So if I'm using the dot product and I start to sum keys, ai times ki, sum them up. If they're becoming too large, compute the modulo of the partial sum that you had so far, and keeps going. Every time that the sum becomes too large, compute its modulo. Okay, let's continue with our Frechet distance. Last chance for questions about homework 2. Anybody took a look at homework 3 by now? Questions about this one? Okay. Quick reminder, Frechet of one polygonal path P, another polygonal path Q, and a value R. How are we defining the Frechet? We are saying that the Frechet between them is smaller than R, or just returning the Frechet of PQ and the length of the leash is R, if both the person and the dog can walk each one in its own weight, and so that the distance between them never exceeds the length of the leash between the person and the dog. They need to both start at vertex P1 and Q1. They both need to start at Pn and Qn, and at each time step, they each either stay in the same place or progressed from one vertex always to the next vertex. And in the homework, I ask you to generalize this algorithm also to the case that at every step, they can either stay in the same place or jump to the next vertex or jump backward to the previous vertex. And I ask you to both give me an example that it could be that I can use shorter leash for what we call the weak Frechet, where they can move backward. To give me an example of why this allows shorter leash, as well as an algorithm to find it. But now we are talking about the strong Frechet. They can either stay in the same place or moving to the next vertex. And we are building a table of all the possibles I and j, where I and j here means what is the result of the Frechet distance with the same length of the leash R, but not of all of P, but only on the sub-polygon that consists of first vertex, second vertex, all the way up to the ith vertex, abusing notation of the prefix of a string. Now it's a prefix of the polygon, the first I vertices of P, the first j vertices of Q, the same length of the leash. Yes or no? Can I have this legit walk of the dog and the man and the person, never where at every time step they never exceed the distance of R, or not? And of course, that's where we ended last meeting. If at the very first vertex here is P1, here is Q1, if here is the target length of a leash, here is my target length of the leash, and obviously if in P1 and Q1, when they start their trip, they are already in violation of the leash law, then obviously they cannot reach any further. Obviously the answer is no if in P1 and Q1. The answer is no. Now, what is C of 1, comma I, which trip does it mean? The person is stuck at P1. He or she cannot move from P1 because he solves the problem of the prefix of only one vertex, where the dog should reach to QI. So how could it happen? It means that the length of the leash, if I draw now a disk with the length of the leash, I'll take a longer leash here, then if I'll draw this circle, are all the vertices of Q all the way to this vertex are all in blanks of 1. If the answer is no, that's fine. I can still, possibly I can still solve the Frechet distance, but at least if the answer is no, then there is a vertex of Q before Qi that is outside the length of the leash when it's stuck here. Then at least from some vertex and further, the answer to the C1j, the answer should be no. And if you notice, an elegant way to check it is to say, are the distance between P1 and Qj is smaller than R? The distance between P1, the man stuck here, and the dog moved all the way into QJ, make it QJ. And so what does it mean? It means under which condition it will be true. It means that this distance is less than R, and in addition, the dog could have made all the way up to Qj minus 1. So if C of 1j minus 1 is true, and this distance is less than R, then C of 1j is true as well. That's just a way to prevent a double loop over here. And remember, C is a Boolean matrix. It returns yes or no. Okay, finally, what's a loop? I did the initialization. So right now, my table is filled with, it's completely analogous to the LCS and the edit distance. So I filled the first row, I filled the first column. These are already filled with values, yes, no. Hopefully this is yes, yes, no, no, no. Of course, once it becomes no, it continues to be no, yes, 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 yes. And now I'm filling up the first table. Let's think about Cij. How am I, in which order am I filling the table? It happens to be, and it's completely accidental, that our go-to order of scanning a matrix exactly fits to these properties that we need. What will be this property? That when I want to compute what is Cij, when I'm about to compute what is Cij, this cell, then this cell already knows what its value, this cell knows what its value, and this cell will know what its value. So what are the conditions to Cij? That first, if the distance between Pi and Qj is larger than R, the answer is that the Cij must be false. You cannot make this trip, at least not if you are planning to end your trip at Cij. Possibly you can make it all the way to this cell, the very last cell, the Mn cell, and what you are asking is just what should be the output of the algorithm is if the very last cell, the lowermost rightmost cell, the Mn cell, is this yes or no. That's all you need to know, because if it's yes, it means that there is a schedule that will guarantee that all the way to the yes, no. But what do I write in Cij? A necessarily, but not sufficient condition is that the distance between Pi and Qj must be at most r. Otherwise, I cannot get to the place that the person is at Pi and the dog is at Qj. That is, I'm pretending once again that this is the last state in my whole trip, that ij is the very last step, and I ask, are they legit when they are standing on this pair of vertices? Is the distance between them larger than the leash or not? And let's say that yes, and let's say that there is any series of steps that ended up by the dog and the man being arriving to this position. So they started over here at P1 Q1, they end over here at Pi and Qj, and I'm asking how come there is such a successful set of trip, successful sequence of step. What happened one time step before they arrived into Pi and Qj? What happened one step ago? Well, I don't know exactly, but it can be only one out of three options. They arrive to the Pi Qj only if one step ago, let's call this guy. Let me zoom in to this picture. So where were they one time step ago, given that now they are at Pi and Qj? Well, it's not hard to analyze, because what are options? Maybe in the very last time step, they both jumped, meaning that one step ago, they were at Pi minus 1, Qj minus 1. Possible. Possibly the person was already at Pi while the dog jumped from Qj minus 1 to Qj. That's another option. Or it was a dog that arrived to its final destination first, and the person was then at Pi minus 1, and then the person will jump at the very last step. The dog was here at its final destination earlier. Which means that if you're looking at the cell of the table, let's say that this is the last cell that I'm referring to, I and j are the very last cell, what are the conditions that this cell is true? Well, first, the distance between these points should be 1, and secondly, there must be a way to reach either this cell or this cell or this cell before one of these three cells must be yes, you can reach it with a leash, with a legit leash. Otherwise, you could have not make it to the very last cell in this way. So all I need to check is Ci minus 1, j minus 1 is true. If this is true and this condition is true, then Cij is true as well. Yes, there is a way to get to the I minus 1, j minus 1 configuration, and they can jump, each one jump simultaneously and make it to the last destination. Or possibly you'll check the case that the dog arrived earlier, so that the person arrived earlier, and the dog is the last one to jump, which means that where is a cell Ci minus 1j is a cell just above the green cell. The cell which is the I-1, J-1 is diagonally, and the cell that represents of the I J-1, I J-1, this cell indicates that the person was already here, the person was already at PI, and what happened in the last time step was that the dog jumped from J-1 to J. Right? So in this way, if I'll ask you what type of alignment matching is the Frechet described, it tells you essentially where were you at each time step, which point in P, capital P, match which point on capital Q. Remember our application. This is a trajectory of a car that drives along some road. This is a trajectory of a car that drove across maybe similar road. And we want to ask, is this the same road? Given that the point that I sampled my GPS are different, the frequency is different, but if it is the same road or similar road, then at every time step, the other car that drove on the same road should be in somewhere close. See that I got a chat that I overlooked into. The Zoom is being recorded. The recording that I'm getting in Twitch are of way better quality than what Zooms does directly. So Twitch has issues of that the picture arrives there later. So, and the people that wrote comments for me on Twitch, I don't always see them in real time. But the recording quality is better. So what I'm doing usually is getting the recording, editing a bit, because its editing tools are also more convenient, and then upload it back to D2L. So yeah. Okay. Clear with everybody? And eventually we return C and N. That is yes or no, the correct answer. And now if I'll ask you what series of steps is possible as the alignment between the dog and the person, you can now trace your way back between the yes of the table, for which, so you can trace your way back to the first location of P1, Q1. I'm asking you to meditate about it a bit more in the homework, but as usual, we first fill the table. It's common to all the dynamic programming, and then we have the cost or a Boolean value over here, and now we can backtrack our way to reconstruct what is a longest common subsequence or the sequence of steps in the edit distance or the series of dog person steps out there, etc. And by the way, you can also look at it as a graph that says every cell will become a vertex of the graph. Every cell is connected to the 3 cells neighboring it, and it's directed graph. That will be a DAG. And all I'm looking for is writing on every cell is this yes or no, if the cell itself is legit or not legit. I'll delete every cell. I'll remove from the graph every cell that requires a man and the dog to be too far away from each other, more than are away from each other. And now my problem is just to find any path in this graph. Right? It's a DAG. I can find a path in this graph. And it's not really important even that that's a DAG. But yeah, such an approach can help you in some of the homework questions. Let's move to the, of course, we cannot avoid looking at Maurice René Fréchet, mathematician, and yeah. And now let's talk about the dynamic time warping. Dynamic time warping is another way to measure similarity between curves that saw a lot and a lot of applications. Again, and think about it now, not as that it's very important for me to know what is exactly the similarity between P and Q, but the general scenario would be I have one curve, P, I have a library of curves Q1, Q2, Q3, and I want to ask is P, what is the nearest neighbor, what is most similar among all the Qi's, what is a curve that is most similar, or are they similar at all? So dynamic time warping was meant saw applications in signature verification. You design some signature that you'll sit that will sit in your bank. Now you're signing in the supermarket, and you're asking is the signature in the supermarket is similar enough to the signature that deposit in the bank. And you can look at it as only the curve in just as a list of locations on the whiteboard, on the paper, or you can add the time component into it, and then it's a timed curve. However, you can ask, here is a signature now, P will be the signature that it was deposit, and here are a few signatures, because if you deposit in the bank only one signature, it might be too arbitrary. I'll ask if the signature from the supermarket is similar to any of the examples that you deposit as signatures of yourself in the bank. That was one applications where dynamic time warping was very successful. Another application where that it was decent is that in deciding about stock policies. Here is the value of the stock in the last 2 weeks. Here is similar path that I saw somewhere from 2 years ago. And I want to know what happened after the first 2 weeks. Is it going up or going down? Let's look at all the similar patterns to the signature in the history. And people use dynamic time warping quite successfully. Can refer you to more literature about it. Okay. We will cover today. Yes, we will finish edit distance, and yes, that will be enough. Thanks for the question, Dylan. Okay, so that's dynamic time warping. What happened? How do we define dynamic time warping? It's again one of the Fifi measured. Fifi is the name of a dog, some dog, family of curves that are obtained by series of steps. At each step, the dog jump or the person jump or the both jump. However, in the Fréchet, I was looking at the maximum distance between the person and the dog at every pair of vertices, at every time step, and said that distance cannot exceed the length of the leash. That is, if one curve, if P is similar to Q all over the place, except of just one point, there is 1,000 points along P, 1,000 points along Q, and they are all very close to each other except of one point of Q, Frechet will say no, the distance between them is too large. You cannot really make this strip unless you are considering this enormous leash. Dynamic time warping says I'm not interested in the maximum length of the leash. I want to take something like the average. It's a bit hard to define what is exactly the average, so it says, you know what, just sum up the length of the leash at every time step, and that's the value that you are trying to minimize. Find a schedule, find a series of steps who moves when, such that when you measure the length of the leash at every step, you'll get something as small as possible. So definition of dynamic time warping, like because some of the time becoming longer or smaller if the dog or person moving fast or staying still. Rules are similar to the Frechet. The person starts at P1 and ends at Pn. The dog starts at Q1 and ends at Qn. At each time step, either the person jumps to the next vertex or the dog or both. And after every such jump, I measure the length of the leash between them. So if I have n vertices here and n vertices here, then the minimum number of time steps that I need will be n if they both jump at every time step. The maximum number will be 2n if they try to go as slow as possible. And once again, the assumption is that that the dynamic time warping measure a distance between the curve. That is, if P is closer to Q, has a smaller distance to Q versus a distance from P to Q prime, then I'll think that Q is more similar out of a library of curves. I think that we exhausted this animation. Okay, you have a list of various applications that used it. Well, people are using it to cluster trajectories of animal migrations. People are using it to cluster signals that are changing for speech recognition. It's not even though as a speech recognition it's a bit passé and so on. So let's drive our dynamic time warping. The notation is just as before. P of 1 dot I is a sub-polygonal path that consists of the first I vertices of P. And that's why so as before, P of 1 dot I, Q 1 dot J are the prefixes, and Cij will be the dynamic value of the dynamic time warping, that is the sum of length of the leashes, minimum sum of length of leashes, in all the trips that start at P1 Q1 and ends at Pi Qj. They need to start at the beginning, they need to end at the end, and let's initialize our table. This time it stores values. This time we need to store values. At Cij, it's not only Boolean values. What is P1 minus Q1, what we are storing between in C11? It's the length of the leash that happens at the very beginning of the curve. It's the length, it's the Euclidean distance between P1 and Q1. And now, what is C of 1 comma J? C of 1 comma J would mean the person is stacked at P1, the dog moved between Q1, Q2, Q3, Q4, Q5, if J equals 5, And what is there? And C of 1,5 is the sum of lengths of the sum of all these distances. The person cannot move. The dog, the only thing that it can do is to jump from one vertex to the next to the next. And after every jump, we check what's the distance to the person and we add it to this sum. And once again, if you want to minimize it, not to do two nested loop, you'll just say that the distance up to the jth part, up to the jth part, is just the sum of lengths of the leashes, up to the fourth vertex plus one more jump, but the very last jump, both for the person and for the dog. Just the opposite. Any questions so far? All very quiet. It's exactly the same philosophy that we saw in dynamic time warping, in edit distance, LCS, and Frechet. Once again, we are saying if they ever arrived into the PIQJ state, what should be CIJ? Well, no matter what happens before, if they arrived to the case of PIQJ, then I must add to the sum the length of the current leash between them. That's the last step. That's the last, as much as I know, that's the very last setting, configuration between them. Let's sum up the length of the leash before that. What else should I add to compute CIJ? So I know that CIJ is the length between PI plus QJ, no matter what. Plus what? Now I need to sum up lengths of leashes that somehow leads all the way to PIQJ. What's my options? What happened one time step ago along the best schedule of who jumps when? What happens one time step ago? Once again, like in the Frechet, possibly one time step ago, the person and the dog was at QJ minus 1, PI minus 1, and they both jump. What's the optimal cost? Cut and paste lemma, he didn't say it today yet. Cut and paste lemma, what would be the schedule that will lead me from 1, 1 to QJ minus 1, PI minus 1? I'll just use the best schedule, the minimum sum of lengths of leashes that leads me to this step, plus the very last step. So in this case, I will add CI minus 1, J minus 1. Or possibly, in the best schedule, that the dog was already at QJ and the person was taking its time, and the person was at PI minus 1. So this, the sum of lengths of leashes that leads to this configuration is encapsulated in I minus 1J. That's the total sum of lengths of leashes that leads me to this configuration of PI minus 1 QJ. And similarly for CIJ minus 1. So I have three options to the setting before. Right? One of these three options happens in the optimum scheduling that leads them to PI to QJ. Which one of the three should I take? Somebody spell it out. The smallest. Just I'll decide about the sequence of steps that leads me to the smallest value. So CIJ is just P, the distance between, it's not minus, I'm sorry, it's not plus, it's minus. The distance from PI to QJ, plus, let's look at these three values. And let's take the minimum between the three of these values, right? Because that leads to a best way to get to pi qj. So that's the only difference between Frechet versus dynamic time warping. It's the same loop, except that what we just said, Cij is just the distance from pi to qj, the length of the leash at the very last moment, plus the minimum among the last three configurations. And the full algorithm would be, after the initialization, the same loop that we saw before. For I goes from 1 to n, for j goes from 1 to n. That guarantees that C both these three values already computed when I reach Cij. And then just Cij is just the length of the leash at the ij scenario plus the minimum of these three values. And the actual dynamic time warping is written as always in the table. It will be written the same spell as before. The minimum, the value of the DTW of PQ will appear here in this cell. And now, giving this number, I can backtrack. I'll let you think how. You do need to think how, but I can find which path is corresponding to this minimum, which in turn tells me exactly what is scheduled. That is, what is the alignment. Which vertex here matches which single or multiple vertices over here, right? We saw this example. We will be done in a second. We saw this example last class that so this example, a lot of vertices. Here, the dog, the man, will start over here, and probably in the minimum dynamic time warping, one schedule is to match this vertex to this vertex, but that requires a very long leash. It's much easier to say, let them both jump, and now the person needs to stay still. That is, I have a set of vertices of Q that are all matched to the same vertex of P, and then they finally both jump at the end. So it's just an alignment or a matching, except that this matching is not one-to-one, but you don't have any crossing, right? If the person move backward, if the person move forward, the dog has to move forward as well. That's why you will not have crossing of the lengths of the leash, at least not as a line, as a straight line. Of course, when the curves are all wiggly, then there might be crossing, not guaranteed to be planar. Okay, and I'm just done with these four algorithms. I think that I'll show you another one or two examples of dynamic time warping, but for homework 3, that's all that is covered. What's the memory to all these algorithms? The memory requirement is, if we want to be able to reconstruct the path, that is to find the alignment, we need the whole table, to store the whole table. Problematic if m times n is large. If we just want to know what is the value that is written here, it is just to ask, is P more similar to Q or to Q prime? And then it's enough to store 2 rows or 2 columns from the table. Why does it make a difference 2 row, 2 column? Because maybe P is much larger than Q, then I'll decide that I'll store 2 rows, but you have to have at least 2. And then you're doing this choreography of each time reading from one row, writing into another. And you can switch between them if in the case that it's symmetric. For dynamic time warping, it's symmetric. Actually, for all the 3 examples besides the edit distance was the only case that the distance might be different because the cost of insertion might be different than the cost of deletion. Questions, people? Okay, thanks everybody. For the Frechet, you have the Wikipedia page, and actually also for the dynamic time warping. The Wikipedia sites are actually quite good. You'll find it in different books, but I really would go first to Wiki or to the slides themselves.